Hello everyone, we're going to be going through the counting principles, permutations, and combinations sections of Unit 7, which is talking about probability. This is a little bit different than statistics, but not quite 100% different. We'll actually be using some of this stuff together a little bit later on in the unit. So, a sample space of an event is all possible outcomes of that event. So if you're picking different sandwiches, if you're arranging letters, if you're picking out an outfit to wear, it's every possible outcome that you could have. So every possible outfit you could make, even if they don't match, every possible type of sandwich you could make, even if it doesn't sound good, like ham and peanut butter don't really sound good together, but if those are two of your choices, then that would be a possible sandwich that you could make. It's not asking you if you would make it or not, it's just asking all of the possible outcomes there are. So to find how many things are in the sample space, we can use what's called the counting principle. The counting principle states that if one event can happen in X ways and a second event can happen in Y ways, then they can happen together in X times Y ways. And if there's another one in there, it would just be X times Y times Z. So, looking at an example quickly here. A school lunch consists of an entree, a dessert, and a beverage. There's 4 entrees, 3 desserts, and 7 beverages from which to choose. How many different lunches can be made? So all you're going to do is you're going to take those 4 entrees, you're going to take those 3 desserts, and you're going to take those 7 beverages, and you are going to go ahead and multiply them together. So 4 times 7 times 3, if you do that in a calculator, ends up being 84 different lunches you can possibly make. So that is your answer, 84. Look at another example. How many different license plates can be created if each plate consists of 4 letters followed by 3 numbers? If there is no repetition. So we're going to start, we're going to have 4 letters, so 1, 2, 3, 4. So that's L1, L2, L3, and L4. And then we're going to have 3 numbers, 1, 2, 3. So the first number, the second number, and the third number. Well, we know there's 26 letters, so we're going to have 26. And now we're not repeating, so once you take that first one out, we'd only have 25. And then 24, and then 23. And again, those are being multiplied. The numbers, there's actually 10 numbers. There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that'd be 10. Again, we can't repeat, so it would be 9 and 8. If you multiply those all together in a calculator, you get a ridiculously big number, which is, I'm going to write it up here so I have room, 2,258,336,000. And that ends up being your answer for that first part. Now if we do allow repetition, it changes it just a little bit. So now instead of having 26 times 26, times 25 times 24 times 23, we're actually going to have 26 times 26 times 26 times 26, because we repeat those letters now. So after you use the first one, it doesn't change it. And the same thing happens with the numbers. Instead of having 10 times 9 times 8, it's going to be 10 times 10 times 10. Because we are allowed to repeat them. So you have, after the first one is picked, you still have all 10 digits. And again, this gives you an even bigger number now because you're multiplying larger numbers. It ends up being 456,976,000, which again is really big. And you would use a calculator to multiply that out. And the last example here for this. How many different ways can the letters of the word pencil be arranged if the first letter has to be a consonant? So the word pencil has 6 letters in it. So 1, 2, 3, 4, 5, 6. And you'll notice that I'm making these blanks here so that I can fill things in. I know how many I'm going to have. And it says that the first letter has to be a consonant. Well, P, N, C, and L are all consonants, so we have 4 choices for our first letter. After that, it doesn't matter. We have 5 other ones, and then 4, 3, 2, and 1 left because we're not repeating, we're using every single one of the letters. So if you multiply 5 times 4 times 5 times 3 times 2 times 1, you end up with 480. So that's the counting principle. Pretty straightforward. Permutations are a little bit different. A permutation is an arrangement of objects or people or numbers where order matters. So order matters for these ones. So whatever's picked first, second, third is different than if you mix up the order. To find the number of ways n objects can be arranged, we use NPN. So this is the number of permutations, and the way you do that is you take the first number and multiply it by 1 less, and you multiply it by 1 less than that, all the way down until you get to 2 times 1. So you multiply everything all the way down there. If we're not using all of them, we're going to use NPR. And this changes it just a little because we're still going to start with n, multiply it by 1 less, and then multiply it by 2 less. But we're only going to go out, we're only going to have our spaces to fill in. So the second letter here tells you how many spaces to put. And this first letter, tells you what to start with. Alright, so a couple of examples very quickly here. We have the first one here, which is 4p4. So what that means is the second number there tells you how many spaces there are going to be. So 1, 2, 3, 4. And the first number tells you what you're starting at. So this is starting at 4, 3, 2, and 1. And when you multiply those out, 4 times 3 times 2 times 1 gives you 24 as your answer for question number 1. Number 2, also pretty straightforward. Again, the second number is telling you that you want 5 spaces. 1, 2, 3, 4, 5. And the first number is telling you you're starting at 8. So this goes 8, 7, 6, 5, and 4. And when you multiply those out, you end up with 6,720 as your answer. How many 4-letter words can be created from the letters in number? So the reason that words is in quotes here is because it's not actually English words, just how many ways can the letters be arranged. So you'll have to notice that there's 1, 2, 3, 4, 5, 6 letters. So we're going to do 6. Order is going to matter, so it's going to be P, and we want to use all of them, so 6P6. So that means there's going to be 6 spaces. We are starting with 6, so 6, 5, 4, 3, 2, 1. And when you multiply those out, you end up with a total of 360. If we try to find the number of arrangements of letters in a word like classroom, we need to adjust our method because some of the letters appear more than once. As you can see, S repeats and O repeats. So if we switch the 2 O's with each other, technically it's another arrangement, but it ends up being the same arrangement of the letters. So if we want to find the correct number of permutations for this, you're actually going to do something a little different. You're still going to have the total number, P, how many there are, so NPN, but this time you're going to divide it by A, and this exclamation point is factorial. So on the top there, that's the permutations, and on the bottom, this is the repeats. So if we wanted to find classroom, you would do, there's 9 letters, so it would be 9p9, and that will be divided by 2 factorial for the O's and 2 factorial for the S's, because you have both of those repeating. So that would end up as, if you multiply the top out and then multiply the bottom out, you will have 90,720. And I didn't write it all out there because the permutation thing on the top is exactly the same as we've been doing before. On the bottom, that 2 factorial means 2 times 1 and then 2 times 1. The last part here, combinations. A combination is a selection of objects in which their order doesn't matter. So this is like picking a group of people to be on a committee for something, that kind of thing. And the way that we represent this is going to be with NCR. And the formula for figuring that out is actually the number of permutations for the thing divided by the number of things taken. So a quick example. Now this is a little different, but it's not that much different. So the first one, 7C7. To figure that out, we're going to do 7P7, and we're going to divide it by that second number there is going to go on the bottom. So 7 factorial on the bottom. And when you multiply that out, you actually end up with just 1. 7C0 is going to be very similar to that. It's going to be 7P0 over 7 factorial. And again, this would end up as 1. I'm going to leave number 3 there. I want you to actually try that on your own. We will go over it in class tomorrow. And number 4. How many different 5-card hands can be dealt from a standard deck? Well, in a standard deck, we know there are 52 cards. And we want to find out how many different hands. It doesn't matter what order you get them in, so it's going to be combinations. And we want 5 of them each. So that means we are going to have 52 P5 over 5 factorial. And I'm actually going to write this one out just so you can see exactly what it looks like. So that would be 5 spaces on the top, starting at 52. So it's 52, 51, 50, 49, and 48. Then on the bottom, you have 5 factorial. And a factorial is just taking that number, 5, multiplying it by 1 less, by 1 less, by 1 less, by 1 less, until you get down to 1. So when you actually multiply those out and divide your final answer, you'll end up with a huge number, 2,598,960. And this last part down here. What I would like you to do is find out how many different, I want you to do this on your own. I want you to find out how many different 3-letter consonants there are. And I want you to find out how many 2-letter vowels can be chosen. Okay, so if you can't remember, I'll remind you that there are 21 consonants and there are 5 vowels in the alphabet. So you have 21 consonants, you're looking for 3 of them. You have 5 vowels, you're looking for 2 of them. So try that on your own, and we will go over it in class tomorrow. I hope you have a wonderful evening, and I will see you tomorrow.